if you're given two functions and you need to add, subtract, divide, multiply these fractions.
No.
So if we're adding the functions, and we have two, we'll call them f and g. Just quietly enter and get your stuff. All right, so if we're adding them, it's going to look something like this. We're going to go f plus g of x. That means we are adding functions f and g with the same input of x. So although it's going to look the same, what's really happening is I'm inputting this x into here and adding the two functions together. So another way to look at that would be just f of x plus g of x. But we know f of x and we know g of x. So we'd replace that f of x with 2x minus 3. And we replace that g of x. I'm going to go ahead and use parentheses, and you'll see why in a second. But to replace g of x, so I'm substituting that g of x in with x squared plus 1. Oh, is it minus 1? Okay. Minus 1. All right, then we're going to go ahead and simplify. Well, we're just going to bring that x squared out front. We'll have plus 2x. We'll have negative 3 minus 1, which would be minus 4. So f plus g of x would just result in x squared plus 2x minus 4. The difference is going to be the same, except we'll have a negative sign in front of that g. So we do f minus g of x, which would also just be f of x minus g of x. Here's where you really want to make sure you're using parentheses to substitute stuff in. So if I substitute that f of x in, we would have 2x minus 3, and we'd subtract with parentheses x squared minus 1. Now we need to make sure we distribute that negative sign to give us 2x minus 3 minus x squared plus 1. In fact, the same thing happened when we added. I actually distributed this plus sign. But when you distribute a plus sign, it has no effect on the numbers after it. So the same thing's happening. It's just you can see it more when we have a negative sign. So make sure whenever you have a negative sign, you're asking yourself, do I need parentheses or do I not? In this case, we absolutely do, so we need to distribute that negative sign. So this is going to end up being just negative x squared plus 2x minus 2. Product isn't that big of a difference. We just changed that addition and subtraction sign to a multiplication sign. So for our product, we would have f times g of x, which would look just like f of x times g of x. Once again, when I substitute stuff in, I'm going to make sure to use parentheses. So we'll use parentheses around the f of x. So we are going to have 2x minus 3. That's a terrible 3. That's a better 3. And we're going to multiply that by x squared minus 1. We have a binomial times a binomial. I know some of us use FOIL. That'd be first, outside, inside, last. I usually never use that. I usually just use distributing, because distributing works for a binomial times a binomial. It works for a monomial times a binomial. It works for a binomial times a trinomial. It works for all of these. And when you distribute, you just take the first number and distribute to both of the other two. So that'd be 2x times x squared, which would be 2x cubed. 2x times a negative 1 would be negative 2x. Then I follow that up with taking that next number, that negative 3, and distributing it to both of those as well. Well, that's going to result in negative 3 times x squared, which is negative 3x squared. Negative 3 times a negative 1, which will become a positive 3. Now I just organize it from biggest power to smallest power. So we're going to have that 2x cubed minus 3x squared minus 2x plus 3. Quotient, we're just going to put a division sign between them. So for quotient, it'd be f divided by g of x, which would be the same thing as f of x divided by g of x. There's one big thing we need to note, though. We have a fraction. Fractions automatically limit a number in our domain. Your denominator can never be 0. Whenever you're dealing with fractions, you should always remember your denominator cannot be 0. I don't have a ton of room, so I'm going to just put a little comma and just try to squeak in there that g of x cannot be 0. I think I got it in there mostly, but you can write it bigger. You have more space than I do. So g of x cannot be 0. So when we're doing f of x over g of x, that is just going to be 2x minus 3 over our g of x, which is just x squared minus 1. I'm not asking us to simplify it. We'll learn how to divide these later, hopefully if we have time, using synthetic and regular division. But right now we're just going to leave it as is. We have 2x minus 3 over x squared minus 1. But I have to tell the person looking at this what values don't work for sure. Safa. 1 and negative 1. So x cannot be 1 or negative 1. I'm just going to put a positive negative 1. If I plug a positive 1 in, we have 1 squared minus 1, which is 0. If I plug a negative 1 in, negative 1 squared minus 1 is also 0. Keep that in the back of your mind whenever you're using fractions with combining, compositing, or decomposing functions. Think about your denominator cannot be 0. Because that leads us to the next big thing, and that's the exact same thing. Domain. We are talking about a domain of a new function. We are combining two functions together to make a brand new function. That means that new function I just created has to adhere to both of the domains of the original functions. So let's look at what we have here. We have an example. F of x equals square root of x. And g of x equals the square root of 4 minus x squared. We have two equations right there. We're going to combine them using division for both of these. Which means I need to know the domain of function f, and I need to know the domain of function g in order to figure out what happens when I compose them together. So let's talk about their domains. The domain of f of x. Can someone tell me the domain of f of x? In other words, what values am I allowed to plug into it? Russ?
X
Greater than or equal to 0. Yes, I'm going to put it into interval notation. You had it right, because x needs to be bigger than or equal to 0, so it'd be 0 to infinity with 0 on the bracket. All right, can someone give me the domain of g of x? It's going to be slightly harder. Yes?
Would it be negative infinity? No, okay. You're right. You're right down. So.
No, I didn't write it down because. So you're saying negative infinity? Does negative 3 work in here?
Yeah.
So 4 minus, well, negative 3 would be a positive 9 when we square it. 4 minus 9 would be a negative. Am I allowed to take a square root of a negative number? No, we can't take, so this has to be positive. So negative 3 doesn't work, so it can't be negative infinity. So it can't be negative infinity. It actually has a nice start and end point. We're getting closer. No? Closer. I agree with the 2. I agree with the 2. The 2 is in there somewhere. Oh, yeah. It is negative 2 to 2. And let's talk about why. Well, if you plug an... What was that?
What? Wait, I have a question.
Yes.
Can you put x has to be less than the absolute value of 2? Absolute value of 4.
Yes, you could structure one that has an and statement between it. Yes. We're just going to stick with it like this. And let's talk about why. What goes under here cannot be a negative number. So 4 minus x squared must be bigger than or equal to 0. So if you look at what makes this 0, a 2 and a negative 2 would make this 0. Negative 2 squared would be 4 minus 4. That's where that 4 came from. I think you were the one talking about 4? Yeah. And if I plug a 2 in, 2 squared is 4. 4 minus 4 is 0. If you plug anything else between those, it would also work. 1 works. 4 minus 1 squared is a positive number. 4 minus 0 squared, 4 minus a negative 1 squared. Negative 3 does not work. 3 also does not work. Yes? It is actually a half circle. Yes, and that's exactly, I mean, it's been in our homework, the last 3 homeworks, right? It was in the last one. I think it's been the last 3 homeworks that you guys should, right, Mark? You should recognize this is just a half circle. If you realize this is a half circle, this is super easy because you're just like, oh, it's got a radius of 2. It's a half circle with a radius of 2. It just goes from negative 2 to 2. And I've said that, I think, 2 or 3 lessons in a row. The quicker you realize this is a half circle, the easier these problems become because you're going to keep seeing them in your math classes. All right, anyway, we got our domains. We got our domains of f of x and g of x. Now we're supposed to combine the 2 functions together. We're supposed to do f of x over g of x, which in this case would be square root of x over square root of 4 minus x squared. We're not simplifying it, we're leaving it as is. However, I'm supposed to come up with a domain for this. Now, when I come up with a domain, that domain has to work for both of these functions. In other words, this says 0 to infinity works for f of x, so I could pick 4 for that one. So I could plug 4 in here, but 4 doesn't work in the bottom. So 4 is not in the domain of the entire function. It's just in part of the function. Safa? Okay. So what you're going to want to look for when you come up with your entire function's domain, you're going to basically graph both of your domains. You don't have to graph it. Just think about it this way. This would be the only time I actually graph it. So let's look at the domain of f of x, and let's look at the domain of g of x on a graph. F of x was from 0 to infinity. So if I was to graph that, I'd make this 0 and say this goes to infinity. Let's go ahead and say this is 2. Let's say this is negative 2. For g of x, we said the domain was between negative 2 and 2. So if I was to graph that, we would have a negative 2. We would have a 2, bracket, and we would shade that in. What domain works for both of them is going to be our intersection. Yeah, do you have answers? What was that? 0 to 2? Yeah, I agree. It'd be from 0 to 2. It is your intersection of domains will be your domain. That is our intersection. Bless you. So our actual domain will be 0 to 2. Am I using brackets, parentheses, or maybe a combination of both? Mark?
Bracket.
On both of them?
Well, now I'm unsure.
I'm just asking.
Yes.
Yes? Okay. So we'll put a bracket on 0. We'll put a bracket on 2. It makes sense. 100% makes sense. Is 0 in domain of f of x and g of x?
Yeah.
Is 2 in the domain of f of x and g of x? Yes. So it makes sense that I'd use a bracket on both of them. However, what did I say you have to think about whenever it's a fraction? It can't be 0 in the denominator. Are there any numbers between 0 and 2 that make it 0 in the denominator? 2.
The square is 4.
So although it looks like it should be a bracket, because of that, we're actually going to use a parenthesis because 2 would make the denominator 0. This is like the hardest example. So this isn't going to be every single problem we have. It's just whenever you're dealing with fractions, make sure you ask yourself, does it make 0 in the denominator? All right, the good thing is after we did that one, it's going to make the other one a lot easier because this one is g of x over f of x. which would be square root of 4 minus x squared over square root of x. We did all of the heavy lifting because we said the domain is bracket 0 to bracket 2 unless one of those numbers does not or makes the denominator 0. So we're starting off thinking, is it bracket 0 to bracket 2?
No.
Or is one of those numbers make the denominator 0?
Oh, yeah, 0 does.
0 does, so we would need to put a parenthesis around the 0 since that one would make the denominator 0. So this is a really tough problem. Most of the time you just have to find the intersection. This is one of those rare cases where the intersection contains a number that actually breaks the new function. All right? So you kind of have to balance function 1 with function 2's domain. Also look to see if it breaks your new function. And 2 would break the top one, 0 would break the next one. All right, let's move on to composite of functions. I almost put the wrong emphasis on the wrong syllable. All right, this is our fog in Goff. And you can do more. But this is where we're starting at. So look at, it looks like fog. You guys never said that in Algebra 2?
No, we
Oh,
have.
yeah.
Okay.
No, she
Whew.
got mad at me.
I said Goff. Goff.
No, I thought you said gone.
Because I went, haha, golf. And then she's like,
It's not golf, it's GMO.
Okay, so fog isn't really fog, it's actually f of g, but I don't care if you call it fog. It's just if it keeps it in your head and you learn it. So that actually is read f of g of x. But I would think anyone that studies math knows what you mean if you're doing fog or Goff. If you have function f of x, Mark.
Sorry.
Him. Okay, so that's f of g of x. In other words, can be rewritten as this, which is also f of g of x. I think a good way to think about this is what's happening is x is our input. And x would be input into g. So if that was a 2, I'd put 2 into function g and get an answer. Then I would take that value and it would become the input of f. It's just a series of inputs. Once again, it's changing your input of g, which then becomes your input of f. Changing the order of the letter matters. If I do g of f of x, that means I'm going to take that x value and put it in for my f. And whatever results from that, I'm going to plug it into g. In other words, it'd be g of f of x. We always work from inside out. So let's do some examples. So our first example is we have f of x equaling x plus 2. We have g of x equaling 4 minus x squared. It says find f of g of x. So in other words, I'm trying to just do f of g of x. But I know g of x. So we're really doing f of, and g of x is actually 4 minus x squared. So I start on the inside. I change my g's input to x. It was already x, so I really didn't change anything. But I'm saying x is okay, so we change it to just 4 minus x squared. Now, our x's input is now 4 minus x squared. So anytime I see an x, I'm going to replace it with 4 minus x squared. So that's going to result in, instead of that x, so what I'm replacing is that 4 minus x squared, and we still have that plus 2 on the end. So once again, I just replaced that x with 4 minus x squared. Then we simplify, and I'd have negative x squared plus 6. Our next one, we're doing g of f of negative 2. We're going to do this in 2 different ways. Whatever way makes sense to you, do it that way. All right, the first way is to look at what it means mathematically. So it's saying g of f of negative 2. So we are taking negative 2 and plugging in for our x of our f of x. So that would be g of, we're plugging negative 2 in for that x, so it would be negative 2 plus 2, which would be g of 0. Well, g of 0 is just replacing that x with 0. So we would have 4 minus 0 squared, which is just 4. Here's another way to do it. It really is the same way. It just looks a little bit different, and some people like to do it this way. The first thing I'm going to do is I'm going to find f of negative 2. So this is a different method. Or we can find f of negative 2, which would be negative 2 plus 2, which equals 0. And then we do g of whatever results. So that'd be g of 0, which would equal 4 minus 0 squared equals 4. It is the same, but some people really like to do it in individual parts rather than having to write it all like this. Especially when they have like 3 letters, like I do g of f of h or z. So sometimes when you have 3 of them, you don't want to keep writing it out. You're just like, okay, take that number and plug into the first one. What I get out, plug into the next one. What I get out, plug into the next one. So some people really like this. Some people like this one. No one's better or worse than the other one. Just pick one of those 2 methods. But Ross, you are right. It's the exact same stuff happening. And they both result in 4, right? All right, the last one. We have f of x equals x squared. Are we good with this slide? All right. All right, so we have f of x equals x squared minus 9, and g of x equals square root of 9 minus x squared. We're supposed to find f of g of x, and we're supposed to find its domain. So let's find f of g of x first. So remember, f of g of x is really just f of g of x. That means whatever's here, I'm going to plug into my g function and see what results. Well, it doesn't change my g function at all, so I really just have f of square root of 9 minus x squared. I'm going to work downwards on this one so I have a little bit more room on the off to the side. Well, that's going to equal, our f would be square root of 9 minus x squared. That whole thing would be squared minus 9. Well, the square root and the square are going to cancel out. We'll be left with 9 minus x squared minus 9. Our 9s would cancel out, and I would just be left with negative x squared. That's just it. But there's a twist to it. How much time?
Find the domain.
Find the domain. And why would the domain be important?
Because it can't be what it can't be.
It can't be what it can't be. That's the best way I've heard it put today. And what I want to show you right now is take out your calculators. Take out your calculators. We just proved that these 2 things are the same, right? Didn't really prove, we just showed that these 2 things are the same. I didn't break any mathematical equations or anything like that. What I want you to do is in your y equals, type this one in and graph it. We'll see if my my Wabbit's working.
Wait, which one are you typing?
I'm going to type in that, well, if I can turn mine on. My Wabbit. All right, we are going to type in, I don't even have mine in front of me, that first one. So we're going to type in that square root of 9 minus x squared minus 9. Which is probably going to take some parentheses. So I'm going to open with parentheses. I'm going to hit my square root. Then I'm going to do 9 minus x squared.
Where's the x squared?
Then I'm going to close that parentheses. I'm going to close my next parentheses. I'm going to square that.
It's a line.
And I'm going to hit mine. Hopefully it's not a line.
You're doing it so fast.
I've done this before in my life.
What'd you press?
I pressed
Like after
I got a syntax.
open parenthesis,
No, yeah, no. I mean after you put it all in.
graph.
I
But
just
make
don't
sure
want
none of your plots are on. If you have anything up here that's on, scroll up to it and turn it off. You probably still have data plots on.
How do you put the X
Wait,
in
do you
there?
zoom out?
You just hit the X.
I'm super
Wait,
cool.
how do you turn it? Stat.
Wait,
Just
where
scroll
am
up.
I?
Oh,
They should say what plots are on.
What's the
Like some of these might be dark.
Oh.
Wait, it's invisible.
Okay, I don't have a ton of time for this. This is just graphing a function, so maybe go home and make
Where'd
sure
it
you're
go?
practicing that.
Wait,
Zoom standard.
what's supposed to be on?
Nothing should be on.
Oh. Okay.
I got it. Oh my gosh! Oh my gosh! Look! Oh my god!
Wait.
Is that negative x squared when you hit graph?
Yeah.
Is it though?
Wait, yeah, it's like square but upside down.
I just want you to look at something.
Uh-oh.
Do you see this gap here?
Yeah.
Do you
No
see that
way.
gap there?
It doesn't go forever then.
It doesn't go forever. It's not exactly negative x squared. If you graph negative x squared,
It would go
these
forever.
lines would be filled in.
Tricky.
So what's important, guys, what's important is that those two equations are equal to each other as long as we limit its domain. So let's look here. If you look, this one, negative 3 to 3 is its domain. So that means negative 3 to 3 must be the domain of my other function. Let's look at why we would know that. Well, when we composite these together, we have to look at the domains of the original functions. So let's do domains. Our domain of our function f of x. What is our f of x's domain? This is the one you want to jump on because you almost can't get it wrong. Yes. Negative infinity to infinity. You're allowed to plug in whatever you want. Our g of x, however, has limits. This cannot be 0. Once again, if you notice this is a half circle with a radius of 3, our domain is going to be
Negative 3 with a like bracket.
Yep.
Negative 3, comma 3 close bracket.
Yep. So what is the intersection of negative infinity to infinity and negative 3 to 3? In other words, which numbers do they share? Just the g of x ones. So your domain
Can it not be?
of, hold on, let me finish this, of f of g of x would just be negative 3 to 3. So yes, our equation is negative x squared, but we can only graph it from negative 3 to 3 because those are the only numbers I can plug into this one. Yes?
What? Doesn't it be parentheses though?
It needs to be brackets actually
Oh, I know.
because negative 3 is included in this one,
Yeah.
3 is included in this one, and it's definitely included in this one
Yeah.
because that's negative to infinity, and there are no fractions for me to break it.
Really?
If I plug negative 3 into this, it will work. If I plug 3 into this, it will work.
Okay, that's good.
Yep. Okay, so that's the big effect on domain. So although it looks like it's negative x squared alone, if you don't restrict the domain, it isn't the same function as you started with. All right, the last thing we're going to talk about is decomposing functions. That is going the other direction. That is, I'm going to break this apart into two individual functions and show how I could put it back together if I wanted to. The easiest way to do this is pick something that's in parentheses or under a square root or between absolute values. So what I'm looking at is this x plus 2. What I'm going to do is I'm going to label my first function, let's call it f of x. I'm going to make that equal to x plus 2. My other function, it's kind of like I just pulled this out and I'm replacing this with a holder variable. So g of x is then going to become 1 over x squared. Because if I pulled up this x plus 2 and plugged it in place of this x, I would have my original 1 over x plus 2. Now keep track of what I just said. If I take this and insert it in there, I would then have the original equation. So the map work to putting these back together would actually be g of f of x. Because I need to take f of x and actually insert it in there to make it work. The other direction would be taking this and plugging it in for there, which wouldn't make sense because then I would have 1 over x squared plus 2. So order matters, which we would further go out and write this as g of f of x. All right, let's go ahead and do that for this next one. We're supposed to do it 2 different ways. The first way is we're going to do the exact same way I did the one above. I'm going to look at something that's underneath the square root. And that is 8 minus x. So I'm basically pulling out 8 minus x, and now there's a hole right there. In that place, I'm just going to put an x. So my g of x is then going to be cube root of x over 5. In order to reinsert these functions, I would have to take f of x and plug it in for that x. So it would have to be f of x being inserted into g of x. So once again, it would look just like the one above, where we'd be doing g of f of x, which would equal gof of x. All right, we're going to do another one. Because it says to do 2. So we're going to do another one. Another way we could do it is we could take everything that's in the numerator and call that one function. So I'm going to name g of x everything in the numerator. We're going to call it cube root 8 minus x. That means I am pulling this entire numerator out. When we pull it out and we're decomposing functions, we're going to replace what I pulled out with an x. So my f of x would then just be x over 5. To recombobulate these, I would have to take my g of x and plug it into my f of x value. So this would actually be f of g of x, or fog. That is how you decompose a function. That's what they call it. All right, guys, that's the end of this lesson, but I didn't get to Safa's question.
So in the last example,
Yeah.
when you ask for functions, you're looking for both like the g of
I'm just asking you to come up with 2 different compositions.
so then that would be like g of f.
Yeah, you could have did f of x's cube. I don't really care what order. What was that? Oh, I see. Such that f, I don't really care about this. Yeah. Just I want me to see that you can decompose it. I think if you can decompose and you understand it, you could change the order and get it that way. Yeah. All right. Do we have any questions from the homework that was due today? Homework-yo. Yeah, Jake.
85.
85?
Yeah.
All right, 85 is 5 minus square root of x is greater than or equal to 0. Well, if I was to graph this, well, our parent function would just be a square root of x. Then it gets flipped and raised up 5. So your graph should look something like that.
Okay.
All right, that is flipped and raised up 5. Because the negative would flip it, and that 5 would raise it up 5. Now, they do ask you to solve for that problem. They said, when is it greater than or equal to 0? So what you're going to tell yourself, well, all of this is greater than 0. In fact, it's greater than 0 until it actually reaches a point somewhere out here. So your big job was to come up with that point. So you're just asking yourself, what value do I plug in for x that actually makes this equal to 0? Well, that's 25. Square root of 25 is 5, so it's 5 minus 5, which would be 0. So in fact, this number way out here would be 25. So our end answer would be any x value between 0 and 25. All right, other questions? 37? 87. 87. Do you have a particular question?
Just the notation.
Oh, okay. So they're asking for when is it greater than 0, correct? Notice it's not greater than or equal to, it's just greater than. So you should have had, if I'm getting the question correct, you just need to know where I got that interval notation from. So you're asking yourself, when is this greater than 0? Well, that's anything that's above y equals 0. So that's all of this. And that's all of this. Unfortunately, when I plug in 2, I actually get 0 out. I don't want 0. I want it to be exactly greater than 2. So that means it goes from negative infinity till we get to 2. Don't include 2. So then we have to union that with 2 to infinity. So you have to write this. Or you could write, there is another way, you can go negative infinity to infinity, and then we can just accept 2 or not 2, or however you want to put. Just let me know that 2 is not part of it. Yep. Other questions?
Is that your tape?
Any other questions? Jacob.
89.
89, that is one of those half circle problems. So 25 minus x squared greater than or equal to 0. That is exactly that definition. This has been the 4th assignment I've put this in.
I mean, it's important.
I think it's really important in mathematics. You're going to keep seeing these over and over and over again. This is going to be a half circle that goes from negative 5 to 5. And I think the bigger point of this is, even if you didn't realize it was a half circle, you should recognize what numbers you're allowed to plug in. You can plug in any number between negative 5 and 5, because negative 5 makes the 0, 5 makes the 0. Anything bigger than 5, 6, 25 minus 6 squared, that doesn't work. 25 minus negative 6 squared, it doesn't work. So you can just plot points. You can plug negative 5 in, a 0 in, a 5 in, and you'd actually come up with these, and you could have came up with that half circle as well. So our end answer is anything from 5 to, or negative 5 to 5, because they're asking for when is it bigger than 0? Well, that's everywhere. And it does say it's including 5 and negative 5, so we could put closed dots on that. All right, other questions? Okay. Then have your